Alright, so morning. Today I'm gonna be showing you how to work with CHIRPS data, specifically in ArcMap. So the first thing that we're gonna do is just open ArcMap over here. So just go there. Doesn't matter if you have 10.3 or 10.2. That's okay. The same tools are gonna be found in both versions of the software. So sometimes it might take a little time to open. Just cancel, just put an X over here. Let's make sure that we select the pointer over here. So the first thing that we're gonna do is find our data, right? So the folder that I sent you guys, the CHIRPS data folder, so let's look for that one. So let's do it like this first, and probably in your lab you will need to connect to folder. So let's go over here and you will go to your USB drive. It's better if you work with an external drive or a hard drive or USB when you're working with GIS data, since sometimes that data can get really big in terms of space. So it's better to have them somewhere, not saved in your computer, because it takes space and then it takes processing power from your computer too. So search over here under my, not this one, under my PC, and this search for my external drive over here. So this is where I have all my data. So make sure that you know in which folder you saved that. Okay. And then we go, so here, ambient drought, data, and this is the folder you guys want to be looking for, CHIRPS lab data students. Hit OK. And you're going to see that you only have one shape file. The shape file is a typical data format for vector data in GIS. Vector data means polygons, lines, circles, points. Right, so let's just add Caribbean Pro. So you're going to see that if you scroll around, you're going to see that you have the greater Atolls of the Caribbean here, right? And you should see meters over here. This is the spatial reference. It's already projected, so we don't have to worry about that. So let's just do a quick hollow. We don't want to have no color at all over the island, so that when we bring the CHIRPS data, we can see the data over the islands. Also, from the beginning, it's good to have everything set up in a way that we know where we're saving stuff. Right, so the first thing that we're going to do is also activate the tools. So if you go to Customize, Extensions, make sure that you have everything checked over here. We're going to be using mostly Spatial Analyst and Geostatistical Analyst, but let's just click on all of them to make sure that every tool is working. Alright, so let's go ahead and go to Geoprocessing, Environments, and over here what we're going to do is tell it where we're going to save the data that we're going to be working on, right? So we want to go to Workspace and select that folder. So if you go scroll back, just select that folder, CHIRPS lab data students, added, and let's see if it, yes, so there you go, and add the other one too. Hit OK. So now we're working on that folder, so everything that we do from now on is going to be saved in that folder. So let's get playing with the data. So first thing that we're going to do is go and get the data. So let's go to the CHIRPS data web page and go to CHIRPS version 2.0. So here we're going to be interested in the global 3-monthly EWX. Right, so remember, this is where we get the anomaly rainfall data. Right, so let's go over here, and I'm going to be working on the years 1994 and 2015, specifically for the months of July, August, and September. But you can do this with the years that you are working on, so don't worry. So let's go to the anomaly data. So let's bring the 1994 first, or the year, or the 3-month year in which you're working. So let's do, so we see over here, this is the one that we want to look for, 1994, July, August, and September. So let's just hit over there. And the good thing about using Chrome is that you can, whenever it's done downloading, you can just bring it in to ArcMap really quick, right? So we just grab it over here and bring it to ArcMap, and when it asks you about creating pyramids, you say no. When I see the data just as it is, and you're gonna see that you're gonna look at a range of colors here in the legend, that it goes from darker to wider in terms of the values. So the wider the values are, the higher the values. But if you want to visualize this in a better way, you just select that color ramp over here and just select a color scheme that makes sense. I like this one, from red, from drier to wetter, right? So let's just select this one, and you will see over here that in the case of 1994, we see that even though some of the areas in the Caribbean were experiencing some anomalies in rainfall, specifically a negative rainfall, which means that like a lot of the rainfall that was supposed to fall over that given time of the year was not falling, so it was in the negatives. We see that the western side of Cuba is experiencing positive anomalies, which means that it's raining more than normal, right? But since we're going to be working only on these 4 islands, we're going to get rid of all of the data around, and we also want to get rid of this negative 999, which is like the no data cells, and we want to get rid of those because then they're going to be we don't want them to be part of the analysis, right? So the first thing that we're going to do is remove the rest of the data. So we're going to focus only on the islands. So let's do something which makes life a lot easier. So let's look for model builder over here. So let's just open that. What this is going to do is it's going to open a second screen, and in that screen we can import the tools that we're going to be using, and we can run them, and we can see step by step everything that we're doing, right? So we don't forget about what we did before, and since we're going to be repeating some of those steps, it's always good to go back to those tools. So the first thing that we're going to do is extract by mask. So what it means is we're going to be using the Caribbean map that we have over there to cut out everything else that is not the Caribbean. So just bring this over here. So you're going to extract by mask. You're going to have an output, which is going to be another raster layer. Raster means that it's based on cells, right? So images, we know that pixels, cells. So that's the 2 data formats we're going to be working on in ArcGIS: vector and raster. Right, so here, let's go to extract by mask, and let's select our anomaly 1994, July, August, and September. And in here, in input raster feature mask data, we're going to choose the Caribbean Pro. Right, so the Caribbean Pro is going to then eliminate all the data that is not associated with the islands. Right, so now let's search for your folder over here. So you should see your folder somewhere. Let's do it again because this is a little confusing. So let me see if I can see it quick. Okay, so now let's go to whatever you have the folder saved. So I have it here, research with students, Caribbean drought, data, and CHIRPS lab data. So let's save it over here. Okay, so it's not, for some reason doesn't want to. Oh, so I need to name it. Okay, so let's name it. It's 1994. And whenever you're saving data, like GIS data, there can't be any space in between like the numbers or the letters that you're writing. Okay, so let's do this. 1994, and this is from July to September. So let's just do that. Let's save that you will see that now is saving in the folder where you have the data saved, and you're giving it this name. Right, so let's hit OK, and you should see something like this. Right, so it's using these two layers that we have over here, right, in order to get this one over here. This is the one that we want. So let's right click over here and add to display. So whenever we're done running this tool, it's gonna automatically add that layer to the screen over there. So let's go to model and let's just run the model, and it's gonna tell us if it's successful. Right, so it's gonna, there you go. So it was successful over there. So let's close it, right, and let's focus on that data now. So we can get rid of this one. Right, we can get rid of this one over here. Remove. Okay, so now we only have data. Right, so this is total rainfall anomalies for the months of July through September. Right, so based on these values over here, we see that some areas did get a lot of positive, like above average or above normal precipitation. So let's do a classified. It's better to visualize it this way. Let's do like 7 classes. We see that negative 99 over there is messing our range a lot because this is the no data value. So we're gonna get rid of it in just a second. So let's go ahead and visualize this quick before we get rid of that negative 99. So we see that for most of the eastern sides of the islands, in the case of Puerto Rico and Jamaica, we see that there's negative areas associated with the data. So it means that there was no rainfall. A lot of rainfall was not falling over, or did not fall, not fell over those months. Right. So in the Dominican Republic, we also see a similar pattern. Right. While in Cuba, we see that in some areas they did get a lot of rainfall, right, above normal rainfall patterns, specifically here in Western Cuba. This is for 1994. All right, so let's go ahead and also get rid of that negative 9999 right there, which is the no data value. This means that in some areas over here for the whole globe, you have areas where there was no like estimate of precipitation for various reasons. Maybe there was no rain gauge closed, there were clouds in between the satellite data. So we want to get rid of those so that we just focus on the values over here that have actual data. Right, so how do we get rid of that? So let's open our model again, right, and let's search for another tool over here. That tool is copy raster. Let's search for that one. Right, so this one, copy raster in data management. So let's bring that one here to the model. So let's focus on this one now. You can move it over here. And what we're gonna do is we're gonna use that raster that we just created, the 1994 0709. Right, so and let's just name it over here. Let's name it CD so that we know it's complete data. And let's leave that like that. It's optional. Ignore background value. Right, so this is where we're gonna write. We want to write the negative 999. Right, so use this option to remove the unwanted values created around the raster data. Right, so that value is gonna be then associated with a 0. Right, so that's what we want. Or and this one it will be distinguished from 0. So that's even better. Right, so it's negative 9999. So that's the value that we want to get rid of over there. All the pixels with this specific will be set to no data indeed. So let's also do this one over here so that we make sure that we remove everything. Right, so let's do that over there. So let's leave everything like it is. We don't want to do anything else. So hopefully this will run. So let's try to now let's just click over here, right click and run. Oh, I forgot something. Let me add this to display. Copy raster, and let's run it. Okay, let's run it. And alright, so it seems like it was successful. So let's go ahead and check that out. So let's close that. Alright, so let's see. Alright, so we see over here, let's look at that range again. So classified. Okay, so let's give it a color scheme. Let's choose something now. Let me see. Let's choose this one. Yeah, this one looks good. So let's give it 7 classes now. Alright. So you see that some areas here, let me highlight this one because I want to see where are we seeing those negative 500 anomalies somewhere over there. Let me focus here. Let's just give it like let's change this one to white so that we see. So yeah, so we see that some areas, specifically in Puerto Rico and in Jamaica, we're experiencing, you know, below total rainfall values of more than 500 millimeters, and that's a lot. See, most of eastern Puerto Rico and most and specifically northwest Jamaica and some areas in Haiti were also experiencing that. So that's really interesting over there, while the rest of western Cuba was experiencing above normal precipitation. So let's go ahead and fix that again so that we see that range. Okay, so now we can get rid of this one. So we're going to be focusing now on the cells that have data over there. Right, so we see a lot of different places. Like this color tends to be associated with the drier areas, right? So from this color over here all the way to the red is the areas that are usually associated with dry, and the purples are the areas that are associated with wetter than normal conditions. Right, so let's do now, let's go ahead and we want to reclassify. So in order to do comparisons between the different years, so we have 1994, we have 1997, we have 2010, 2015. So in order to do comparisons between those years, we want to group some of this like data in terms that we can do comparisons between the other years. So how are we going to do this? So the first thing that we're going to do is, let's go back to that model builder over here. Now let's bring in another tool. So over here, what we're going to do is we're going to go and do reclassify. Classify. You don't have to write it in major caps. I just did that by accident. So reclassify over here. So let's go and check this out. So what we're going to be doing in here is we're going to be using that raster that we just created, the 1994 0709 CD complete data, right? And we're going to be grouping it in 3 groups, right, based on that data, right? And we're going to be only interested in those negative values. Since we're interested in the droughts, we're interested in either these areas we're experiencing an extreme event or severe or moderate, right? So we're going to be, if we go back to the lab, we talk about that area. So we're going to reclassify them using this scheme over here: extreme, severe, and moderate, right? So what we're going to be doing is then go back over here and make sure that this value selector over there is going to do it automatically for you. So let's classify, let's do 4 groups because we need to add 0 to the other groups, specifically the positive ones. Right, so what we're going to be doing is, so we saw that the first group, the breaking point was -300. So anything above -300 is going to be group or reclassify over here, right? So and then anything above -100 is going to be grouped in another group over here. And then we have 0, I believe, is the next one. Right, so 0 is the other breaking point. Right. So let's hit OK, and we should have those 4 groups over there. Right. So this one, yeah, this looks really good. So what we're gonna do now is we're gonna assign values to each of them. And since we're gonna be doing overlay analysis later, it's not good to have them, you know, in just like normal order numbers. We're gonna do 3, 5, 7 because then we can multiply and we can differentiate between the different like rasters and the different groups later when we do the overlay analysis. So it's gonna make sense later, don't worry. So let's go ahead and name this one 3, reclassify this one as 3, let's reclassify this one as 5, let's reclassify this one as 7, and let's reclassify this one as 0. Right, so what it means is that now all the areas that have a value of 3 are areas going to be extreme drought from -300 up. Right, the areas with 5 are going to be severe drought with -100 to -300 over here, and the 7 over here is going to be then moderate drought. Right, so from 0 to -100, while all the positive areas are going to be with 0 because we're not interested in those positive areas in the case of this research. Right, we might go back to them later, but not right now. Right, so let's give this a name. So let's close this and let's just do let's do rec 940709. Okay, so we reclassify the year 1994 and the months July to September. Okay, so let's hit OK, and hopefully this will work. So remember, add to display so that we can automatically see that when it happens. Right, so let's do a reclassify, and let's just run the model to see if it's working. Okay. Alright, so it seemed like it worked, but it seems that there's also an issue with one of the, we can fix that. So over here we see those that 326 over there. We wanna fix that. Let me see. So maybe we can change that. Let me see if we can look at this in a different color scheme. Okay, so I see that this 326 is not something that is noticeable in the map. So we can do another reclassify quick. So if you see that when you do your reclassify, there's something that doesn't make a lot of sense, we can always reclassify again, right? So we're going to be choosing that one now, and you can go to that same tool and you should see the 3. So let's do another reclassify, or let's let me see if I can yeah, let's do another reclassify because that one has already saved the parameters that we chose for the other one. So let's go to rec. Yeah, let's go to this one, and you should see, yeah, so this is what we want. So let's go ahead and reclassify this again. So it's 0, this one is 3, this one is 3, this one is 5, and this one is 7, and this one should be 0. Alright, so let's name that one. So we rec 94 0709, right? So you can remember that when you're doing your year. So if you're doing 2010, so you can do rec 10 07 09. If you're doing like August, September, and October, you can do 08 to 10. So that depends on the data. So you don't have to write exactly. This is just to, so when you're looking at the data, you know how to differentiate between what year and what months you're working on. So we can do, and then just write 2, so that you know that this is second reclassify that you did. Let's see if this one works now. So let's focus here. Let's add display. Let's run it. Alright, so that one looks good. Right, so let's look at this one over here. Let's get rid of that one. Right, so let's get rid of that one. And let's look at color scheme that makes sense for this one. Right, so let's look at something like this over here. Alright, so let's put the 0 in. Let's put the 0 in white, because that just means that those areas that did not experience like any negative or any like below or deficit in rainfall over that given time period. Right, so let's look at the pattern over here quick. Right, so and let's also give this like some labels so that we know what we're looking at. Right, so remember that the 3, we're talking about negative 500 or negative, let's do it easier. So negative 300 or more, right, or higher, or in here we're doing what was it, this one, from negative 100 to, or let's do negative 299 to negative 100, and in this one we're doing negative 99 to 0. Alright. Right, so we can get rid of this one too for now. Right, so now we're focusing. So here, let's look at the areas over here with this color. So you can just go and select this zoom in tool, and you're gonna see that those areas are mostly concentrated over here in eastern Puerto Rico. So those were the areas that experience below rainfall values of more than 300 millimeters over those 3 months, right? And also other areas in the Caribbean was over here in northwestern Jamaica. So you can zoom out a little bit and you can see the whole island, right? But mostly the pattern over here is that most of the Eastern Caribbean, specifically Puerto Rico and the Dominican Republic, were under drought in 1994. And if we see the reports and we see the papers, we know that that was probably one of the most severe drought periods in modern history for the Caribbean, specifically for the Eastern Caribbean, and if we include Jamaica there. But then in Cuba, we see a different pattern. Remember what I told you about the Western Caribbean. In some years you see that under El Nino conditions or under strong westerlies, we see that Western Cuba will get a higher than normal precipitation. If we go back to the maps that we had earlier, that's what we saw over there, right? But in terms of the East, we see that at least Cuba did not experience deficits of more than 300 millimeters over those 3 months, like Puerto Rico, Jamaica, and some areas of Haiti did. But it did experience some areas that were under what we would classify it as a severe drought, right? And also as a moderate drought in some areas in the central parts of the island, right? So this is the first step in the analysis, right? So you're going to repeat this step with all of the months of the year that you're doing, right? And at the end, what we're going to be doing is we're going to be sharing the data and we're going to be doing the overlay analysis together, since we're going to do comparisons between other years. I'm going to be looking then at similarities or differences, like the spatial characteristics of those droughts, right? But the first step is doing this, right? So getting the data, getting rid of the bad values, and then reclassifying or grouping, the values associated with extreme, severe, and moderate drought for the Caribbean. Right, so hopefully this video will, this tutorial will help you in terms of working on getting your lab done and getting your data ready for the next step of analysis. The next step of analysis is going to be overlay analysis, which is just a little bit more complicated. But if we get our data ready for it in the best way possible, I don't think there's going to be major issues with it. All right, so good luck with the lab. I know you guys are going to do a good job. Okay, so let me see, how can I get